Every organism emits volatile compounds, and we are interested in what type of compounds different organisms emit and also how much they take up. And so far most people measured emission of these volatile compounds, but we also want to know how much is actually taken up by different organisms. That's important because if we want to understand what, for example, drives the emissions of these volatiles, we also need to know how much of those emissions are again taken up by other organisms, so that we know how much net volatile emissions there are taken into account, uptake and emissions by different organisms. So it's quite important to know, to understand different ecosystems, interactions between organisms, and I guess in the end, if you would like to make it even broader, then it's also about the climate system, because these compounds also affect the climate system. They are basically like greenhouse gases, and of course it's important to know how much is emitted, how much is taken up, also depending on different environmental factors like temperature or moisture. We have a good team together, I think, that are good in what they're doing in terms of which organisms they study. So we look at soil and the bacteria that sit there. We have someone working with aquatic systems, and some people working with plants and bacteria that sit on plants. So we also try to start out with simple systems. So we do lots of lab experiments where we limit the organisms we study. So we have cultures to see how specific bacteria, how much of these compounds they emit and how much they take up, and then we can make it more and more complex. So then we add more and more organisms and community members to these simple systems to make it more complex. So we try to start out simple and then increase. So the research in my group is interested in a specific type of bacteria, nitrogen-fixing cyanobacteria that sit on moss plants, among others. And what we're interested in is how these different organisms, so the bacteria and the mosses, interact. And it could be that these volatile compounds are quite important mediators of these associations. So basically we bring our knowledge of these organism interactions to the center between plants and bacteria. I guess in the end, with our data, we hope to improve current ecosystem models in terms of carbon cycling, and that is of course also important to understand how climate change impacts ecosystems and how the compounds we study feed back to the climate system, which is of course crucial to understand. The special thing, I think, is that the leader, Rika, she had this good idea to get different people together to work on something that's fun, and we also have now time and resources to do something special. It's really unusual to have this long funding time. It's at least 6 years, so we can actually do things, we can repeat experiments, we can revise experiments, we can even make mistakes and make the next experiments better maybe. But it's really a unique opportunity to have time and resources to start up something completely new here in Copenhagen. What we really want to do is study what hasn't been studied in terms of these volatile compounds. So most people focused on plants, what they emit and how much they emit, but now we really want to know how much is actually produced and also taken up by understudied organisms, soil bacteria, bacteria that sit on other organisms, and so on. So that's quite unique and important for. This is of course important because we increase our basic knowledge of how the world works and the ecosystems we go to. And yes, so of course I'm excited to have these, the chance now to explore something I haven't really worked with before. So these compounds that are emitted by organisms. So far we have studied the organisms, but not so much, not at all these compounds they emit. So that will be very exciting to see if they emit any. Of course they do, but how much, and does it actually affect them and the partners? So I think that's very exciting, and of course it's fun to know we have some time to look into that and to have the resources to really push the field forward.